Well, I mean, you're managing water activity on the surface, and we go back to the principles, right? I mean, meat is theoretically sterile until we contaminate it. So, a whole subprimal on the outside of it, we drop the water activity to the surface, so it becomes an unfavorable environment for bacterial growth. We've got temperature, and then we've got competition.
Hello, meat folks. Welcome back to the MeatsPad podcast. This is your happy, humble host, Phil Bass. We're going to talk a little bit about something that is near and dear to my heart, something that I have taken on as kind of more of an avocation, but I've done a little bit of research in, but then also the individual who's joining us today, Dr. John Scanga of Colorado State University and Eurofins, and we'll talk about that. Both of us kind of have a little bit of a passion on dry aging. So,
great.
Thanks for coming.
Thank you, Dr. Bass.
Yes,
thanks for having me. It's fun to be here today.
Well, so first I got to tell a little bit of background. Dr. Scanga was the co-chair for my PhD, and so a little nervous right now. Hopefully he doesn't ask too hard of questions, especially math, because I don't want to do math in front of everyone, obviously. But no, we've talked a little bit about dry aging here on the podcast. In fact, that's kind of how I got involved originally, was talking about dry aging. But I've kind of set that aside for other topics, but you and I were visiting a little bit about some of the things you were working on and some of the things you've experienced. And I think it's super relevant right now because folks out there who are doing dry aging, and especially in the beef category, we're getting a lot of questions from a food safety side of things. And I think it's important that we address that. And so first off, let's talk a little bit about, can you define dry aging from your perspective, and let's go from there.
Yeah. So, if I look at it, dry aging, it's pretty simple, and we've taught it in basic principles of meat science forever. It's basically the ripening of meat in the atmosphere. So we don't use any packaging or barriers, and really what we're attempting to do is really dehydrate the product and control that spoilage. So there is a component of bacterial growth, mold growth, development that we long believed was a contributor to flavor, but then some of the science has come along here very recently and attributed a lot of those different molds and microorganisms and part of the microbiota that are on those products, and they actually are very critical to the metabolism of the protein and the fat and the flavor development. So it really is controlled spoilage. And one of the fundamental things that we use with that is the dehydrating component of it as well. So you get tenderization, you get a reduction in juiciness, if you will, but that is coupled with that increase in flavor intensity. And the amazing thing is, if we look in the rearview mirror of where we've been as a society with a tremendous amount of disposable income and low inflation and those types of things, consumers were spending a lot of money on food, a lot of money on boutique foods. And so we were buying up the chain, and so dry aging has really taken off, and there's a strong demand both at the retail level and the food service level with this artisan-type product. And so big demand in the industry, which then leads to a shortness of the supply chain and a lack of supply and a lack of capacity to create these products. And so as companies have come on board and building new of these, well, they build new plants and they enter into new regions of inspection and new things that have brought new challenges. So,
yeah, let's talk a little bit about that because I work with a number of dry aging outfits out there. They're regularly calling me and right or wrong, they call me, I guess. And I have had the opportunity to do some of the microbiota research where we're looking at the microbial communities that are growing on the meat. And again, my firm belief from what the data continues to show is that those microbes contribute to that final eating experience, and it's the unique fingerprint of those microbes. And even you may have one particular microbe there, and if the other one that it likes isn't there, it's still kind of not necessarily always going to give you the same result. So it's very artisanal, as you mentioned, which also means that we don't have a lot of knowledge base yet, which is fascinating because if you think about wet aging meat in a vacuum, that's a relatively new concept to humanity. like 1970s kind of new concept. Yet has become the overwhelming majority of meat being aged and processed and distributed in the industrialized world. And we're going back in time essentially to dry aging, to this older phenomenon. So
I'll use a quote from George Carlin. Old fashioned back when botulism was sauce, right? No, you're absolutely right. And in fact, you try to use that argument from a food safety perspective to say, well, we've been dry aging meat forever, and you can't definitively say that we've never really harmed anybody by doing it, but you'd sure like to think that if there were fundamental problems with it, that maybe the incidence of foodborne illness associated with it, and particularly mycotoxins. I mean, I think that's really what we need to talk about is, the molds and the fungi that are growing on this product. Do they have the ability, under the conditions of which we age these products, to actually produce compounds that would be harmful to humans? I mean, that's the fundamental question.
Yep, this is so important. Well, and okay, so briefly, for those who are less familiar with dry aging, the reality is intentionally we allow molds to grow on this stuff. And it's stuff that's floating around the air. I mean, we can inoculate.
Well, and if you think about it, and you've been in a number of dry age facilities across the country. I've been in a number of dry age facilities, and they're all vastly different. Yes. And you have from A to B. So you have the old time facilities that are post and beam. Yeah. I've never been in one that was sawdust floor, but I can imagine those. So you have the old ones that are historical, and they have a much different flavor profile than somebody that's on the other side of the spectrum that's built new ones with, they're very much all in, all out, high sanitation, UV lights, ozonated air, all these different things that really, when you think about, let's take meat out of the equation and let's be, cheesemongers for just a minute. And it's like trying to say, well, we're going to make aged cheese, ripened cheese in a sterile environment. It ain't going to work. I mean, you're going to have cheese, but it's not going to taste the way you want it. And so I see an industry that's done both of those. And so you have products that are labeled as dry aged that really don't have the dry age flavor profile, if you will, which, U.S. consumers are pretty in tune with vanilla. Yeah. We don't eat a lot of strong flavors. We're getting better. So that product fills a pretty good niche. It says dry age on it. It's aged. It has kind of that concentration of beef flavor, but it doesn't have those developed, ripened flavors, if you will. And consumers love that. And then you have, probably one of the best dry age experiences I had actually was in Canada. Yeah. It was in Toronto, and it was like a 135-day dry aged tomahawk, and it was like... It was a new level of eating experience, and so you have that range of it. So I think that's the other thing we have to look at is not all aging facilities are the same. No. We don't use starter cultures, if you will. We could, and I think there's some really cool opportunity in that space. But again, then it goes back to, well, is this controlled growth or uncontrolled growth?
Right. Okay, so. You've mentioned something that we need to definitely address, and molds, as just a normal function of their existence, will produce products. Sometimes this product is what's known as a mycotoxin, and maybe you can define that a little bit for us, and then is it something we need to be concerned about?
Sure. So I'll pretend I'm a microbiologist if you pretend you're a mathematician. How's that? So in essence, a mycotoxin is just that. It's a chemical compound that a mold or a fungi is going to produce that could have different chemical effects on the consumer. They could be neurogenic. They could be pathogenic. They could do all kinds of different things. And again, there's people out there that are rolling their eyes going, that's not even close. And you're right. We can talk to some microbiologists and really get into the toxicology of that. I'm not going to do that today. But the key thing, as I've looked at this, if you look at the vast majority of the populations of fungi and molds that we see on these products, they kind of all have one characteristic in common. And it's a little bit different range, but most of them won't produce those toxins unless their growing conditions are right. And I'll go back to George Carlin. Clostridium botulinum, right? Is the organism in and of itself a problem? No. The problem becomes when the growing conditions are such that it is able to grow, proliferate, and produce botulism toxins. So as long as the conditions of the food are such that we can prevent the outgrowth and prevent the production of the toxin, it's totally safe. Dry aging is the same way. So, and really the big one is, temperature. Most of these products are not going to produce mycotoxins outside of the temperature range at which we are going to ripen these products. Right. So you're not going to dry age meat at the same temperature that you're going to create dry cured salami. Right? Yep. So we're going to be in the refrigerated range, probably less than 40 degrees Fahrenheit, with some humidity. And in those ranges, by and large, the science of these microorganisms suggests that they're not capable of producing toxins and have not been demonstrated to produce toxins. Yeah. So therefore, if in a dry aging environment you control temperature, probably one of your critical control points, or one of the points that both from a quality and safety perspective you would want to measure, you should be good.
Yep. That's been my experience anyway, and that's what the documentation continues to tell me. There's a lot of research out there on mycotoxins, and usually it's going to be when those are produced, it's at those warm temperatures. And really, most of the research is out there on plant-based material, corn, wheat, rye, things like that have been grains that have been temperature abused, but then also have that high humidity. Now we're dealing with a high moisture product, obviously, but we're not in that danger zone temperature range, which is cool how nature kind of put all those bad bugs generally in that one little lump.
Gave them that little characteristic that says, if you're refrigerated, you're fine. And I think the other important thing is, because, if you talk about dry cured products, dry cured ready to eat products, there's a pretty big push, right? A new directive coming out, and so there's some new things in the food safety pipeline looking at that class of products. This is not ready to eat. So this is still very much a raw product. So then heat stability of toxins can become also a concern. So as you think about your HACCP plan, but I think there's some ways, some tools to get us around this, and some tools that can help us validate our process. And so that's the cool thing is, we have the ability to develop food safety processes in these environments, monitor our temperatures, and then identify, what kind of bugs are we dealing with in the process. And I think if we understand that, we understand the growth and the pathogenic characteristics of those bugs, we can build a process that is scientifically sound, meets all the requirements of a science-based HACCP program, and produces a food product that's nutritious, delicious, and safe.
Well, you kind of mentioned too, the safety of the product itself. We're at refrigerated temperatures, so we're limiting any of our real known bugs from becoming a problem. But then there's also the part where, and some of the research that we did was, it's hard to find viable bacteria on dry aged product. I mean, there's publications out there that have demonstrated dry aging is almost its own intervention from a bacterial standpoint. So really, yes, it's the molds that you can see visually. Like, that's the ones that we need to be concerned about. But I mean, this is pretty safe stuff.
Well, I mean, it's you're managing water activity on the surface, and we go back to the principles, right? I mean, meat is theoretically sterile until we contaminate it. So, a whole subprimal on the outside of it, we drop the water activity to the surface, so it becomes an unfavorable environment for bacterial growth. We've got temperature, and then we've got competition, and so that really makes it through that. Well, then you have to further process it, because consumers want dry age, but they don't want to see what dry age.
They don't need a lot of
looks
hair
like.
on it. Yeah,
right,
exactly. Yeah.
Right. Which, come on, I mean, trim your blue cheese off. So, but then you get into some different things, and from a shelf life and a consumer appeal standpoint, can present some new challenges. But again, with good processes and understanding what you're dealing with, you can make a safe product, no problem.
I think you've already addressed it, but maybe we can just summarize some best practices for those who are considering dry aging, and maybe help these folks that are doing dry aging have that conversation with their inspectors, right?
No, absolutely. And as I've worked through this space, I've relied on your research quite a bit to provide consultation to the industry and some of our clients. But so the best practices, the three things you have to control, temperature and humidity are kind of the givens. But I think the one that people overlook is airflow. And that's kind of the cool thing that's out there. And, I think the other thing where we can learn a lot as an industry in these artisanal products is stop acting like meat packers and let's start acting like cheese manufacturers. Yeah. And so there's some really cool technology out there from a refrigeration perspective that uses, glycol versus, just your traditional refrigerants and doesn't necessarily use the old style condensers where you get these huge swings in temperature and humidity and really control that environment and make it stable. I mean, and I think that allows us to do some things. But airflow, I've seen some train wrecks because you build a dry aging room and you don't address airflow in the construction of it, or you just put too much product into it, or you try to overload it. Because man, at Christmas time, everybody wants dry age ribs, and you built that room for an average load. And it's anything but average in the holiday season, and so you overload it, and then you get wave, you get outgrowth, you get slime, you get different colors, you get things that are funky. So your critical control point should be temperature. Temperature range. Refrigerated temperatures less than 40. Probably closer to 40 than closer to 28, the freezing point of meat. So you remember, we want to make sure that these organisms have the ability to grow. Yep. And so, I would probably tell you to be somewhere in the 35 to 38 degree Fahrenheit range. And then humidity. And, I think that's, again, there's a pretty wide range on acceptable humidities that you want to be in. And I'll leave that to you to pick where you want to be. But I think, as long as you're probably less than 80% humidity, probably greater than 45, you're probably going to be in that range. But again, that airflow is so critical to that. And remember, part of the objective of dry aging is drying it. So if your humidity is 80%, you're not going to dry very much. But if your humidity is too dry, you're not going to grow a lot. So again, manage that, but keep in those range and make sure you got airflow. Make sure you can circulate that air, change that air over in that cooler, and really get it to all those surfaces.
Some of the rules of thumb that I'd like to add on to those a little
Correct
bit
me.
is no, not at all, because you see the spectrum all the way from dry aging in Denver where it's 15% humidity to dry aging right on the coast of California where it's 100% humidity and everything in between. Right. And so and those are all going to give different communities of bugs and different flavors, and that's the cool thing about dry aging. It's so unique and so artisanal. It's kind of like if you're a beer fan or a wine fan, you got to have
sourdough.
The beer of the region, or sourdough. Exactly, it's always going to have its own unique flavor. And the environment really does that. And so if you can control humidity, you're absolutely right. That 80% is kind of that sweet spot, 75, 80%. However, if you have trouble with that, that's just the reality. Yep. And that's okay too. Yep. Don't be ashamed of that. Embrace your unique region that you have. Right. And as far as the airflow, some of our research has demonstrated, if you hold your arm out and you just barely blow just enough to feel it, that's about right. That's about what you should be feeling right on the surface of that meat, and that's going to keep that meat from getting slimy, obviously, but also not too dry, because if you make it too dry, nothing can grow. So you just end up with a rock. So, this is so much fun. I can't wait to see what more you can come up with, because you work quite a bit in the food safety world. You claim not to be a microbiologist, but let's be real. You are a jack of all trades, but definitely have a good understanding of microbiology.
Yeah, so I'm kind of in a unique role, and I'll take an opportunity to talk about it.
Tell me about what you do. What's your day job?
And I think, I've talked a lot about this with my colleagues that, at the universities, there's a challenge out there to really retain talent at the university away from the industry. And not that there's not great people at the university. I'm not saying that. But we see people leave the university or leave graduate school and go to the industry, and they never come back. Well, we still have to train the next generation. We need the next generation of meat scientists. We know that. So I'm in a kind of a role now that I'm split time. So I've got 2 part-time jobs. I've actually got 2 full-time jobs that they pay me part-time for. So I'm working at Colorado State University, back on the faculty there in the Center for Red Meat Safety and Quality, and kind of getting the band back together with Dr. Belk and Dr. Delmore and Dr. Nair, and really looking forward to that and research and teaching. But then I'm also a chief science officer with Eurofins Scientific in their meat and food division. And I'm not a microbiologist. They don't let me on the bench. They don't trust me with any of that stuff, which is absolutely true. If Dr. Jornaris would hear, she won't even let me go in the lab to look at it. But what I do there is really just help our meat clients predominantly solve problems, and that could be regulatory problems. It could be dressing practice problems, sanitary dressing, any manufacturing, and just pull on my experience that I've had both in the industry and working with clients and the knowledge of meat science to bring that to the industry to help them be more efficient and safe in their process. So those are kind of my 2 roles, and have got to apply both of those in the dry aging space here recently, and it's just one of those things that it's popping up. Getting questions from the regulators on, is this practice sound? How do we prove it's sound? And we can say we've been doing it forever, but that's not proof. So making sure we have the data to support that. And the other important thing there is the data to support that without, spending $500,000, right? So you got to kind of balance all. Be those
reasonable
things
about it, right?
Yeah.
How'd you get started in the meat sciences?
Well, my story's not that much different than everybody else's. So when I started at Colorado State University. I won't tell you when because I don't want to admit how old I am anymore. I'm not young. But when it was headed to vet school, right? Yeah. Showed up bright and shiny as going to be the next veterinarian. Didn't last very long. And I'll tell you, it wasn't because my grades weren't good. It was because I just didn't like the attitude amongst the profession. I can remember sitting in a seminar, and there was a veterinarian that was on a panel, and some student asked her a question about how she dealt with clients when they lost a patient. And her answer was a scoff of, oh, I don't lose patients. And the level of arrogance, as somebody that grew up in agriculture, I was like, this ain't for me. And so, nope, then I walked into a class with a great dear friend of mine, Kara Gherkin, who works Where Food Comes From, and that was meats judging. And, went up and down the road with meats judging, and she instilled a passion for the industry and started working with the graduate students at that point in time at CSU, and the rest is history. So, and it's been a wonderful industry, and it's great to be here in St. Paul at the Reciprocal Meats Conference with the family. So,
yep, it is, and it is a family. It absolutely is. We mentioned that a lot on MeatsPad. So, Dr. Scanga, thank you so much for joining us. This was fun. I know I've learned something. I know that we have some folks out there that have been asking these questions, and if we can be of a resource to you, please reach out. Info@meatspad.com, and I can get you in contact with Dr. Scanga. And also, are you on the Colorado State website?
Absolutely. You can find me at Colorado State. You can find me on the AMSA website. So or you can track me down through Phil, LinkedIn, Facebook. I don't Instagram.
Nope. That's all right. Well, thank you so much, and we'll talk again.
Phil, thanks for having me.
You bet.
Take care.